My name is Verboom, and I'm going to talk about the results we are developing within CirclesOfLife. The results we develop within will support reducing the environmental footprint of shipyards and enhance circularity in the maritime value chain. But before we start off, sustainability is sometimes a little bit of an abbreviation bingo. So just to clarify, I will shortly explain the three main subjects: SEPI, SCMP, and SLP. So first, SEPI, the Shipyard Environmental Performance Index, which has a focus on shipyard level. The SCMP is the Ship Circular Materials Passport and focuses on the materials and components used to build a ship. And last but not least, the SLP, the Ship Lifecycle Passport, which focuses on the ship as a product. And there is a connection between these three, which I will elaborate on later. So first, we focus on the Shipyard Environmental Performance Index. And like I mentioned, it's called SEPI. On the question how to measure, assess, report, and improve the environmental footprint of shipbuilding processes, the answer for us is SEPI. SEPI focuses on shipyard processes, from the materials that arrive at the yard, the inflow, to how it gets transformed and integrated into a ship, up to how it leaves the yard, either as a ship or as another outflow stream. And that is hopefully done while retaining circular value, like Benedetta elaborated on. And for all these processes, SEPI can help identify the hotspots on the various ESG topics. And even make this assessment comparable by applying a scoring methodology. And it's good to note that SEPI focuses on the non-operational life cycle of a vessel and applies for all yard types, from new build to repair and conversion, all the way to end of life. So we have applied the following strategy to develop the SEPI concept. First, what to measure based on current and future legislation, like CSRD, like mentioned, Circular Economy Action Plan. Where to measure based on a shipyard process model, and how to measure and how to assess, improve, compare, and report. But SEPI is not just about it's not about just start measuring everything and include that in an assessment. It's the other way around. SEPI helps you identify the hotspots in your operation where it can most effectively be improved. And this can be done by improving the measuring detail level or by assessing where to invest in new technology to lower your environmental impact. And SEPI also supports this functionality. And by aligning the SEPI methodology to the current and upcoming rules and legislation, we make sure that the outcome of the SEPI can be reused as input to the reporting requirements and improvement planning. So on the question how to represent the performance of a yard, of a shipyard, we have come up with a scoring methodology, which consists of two axes. And this can be seen on the left side of the screen. There's one horizontal axis, which shows the yard performance on the ESG topics compared to a benchmark for each of the specific topics. And there is a vertical axis, which shows the maturity level of the shipyard, where at the lowest maturity level, the hotspots are calculated on main process level, up to the highest maturity, where hotspots are measured on the most detailed activity level of the process. And that assessment is then supported by a full digital shipyard model with real-time measurements at the highest maturity level. So together with the SEPI concept, CirclesOfLife has developed a generic shipyard model. Here it's really basically represented. The generic shipyard process model, which covers an end-to-end, the full lifecycle scope of shipyards, like I mentioned before, helps identifying the ESG hotspots and supports improvement modeling and planning. So here you can see the generic digital shipyard model just represented by a few blocks, but in the higher maturity levels, where the hotspot assessment is more detailed and information becomes more specific by going from calculated at main level to measured process activities, the generic shipyard model can then be transformed from a generic to a specific digital shipyard model for your yard. And this enables assessment and improvement planning, which, not by coincidence, aligns with standards like ISO 50001 on energy management. So then the question, what have we done so far? We have developed the concept and methodology behind SEPI on how to identify the hotspots and improve environmental impact and circularity for shipyards, including the scoring methodology and maturity levels approach. And based on that output, we are currently developing a SEPI software tool. And of course, we're going to validate the concept and software tool in case studies at the actual yard within the consortium and provide user support combined with a best practice guide. But this will be further discussed by Matthias. So that was it for now on SEPI. If you have any questions, feel free to reach out in the Q&A session. Next up, I will introduce the Ship Lifecycle Passport and the Ship Circular Materials Passport, which focus on material inflow on a product-based perspective. So where the SEPI focuses on assessing and improving circularity and environmental impact on a shipyard level, the Ship Circular Materials Passport and the Ship Lifecycle Passport are the answer to the question how to improve circularity and lower environmental impact on materials, components, and ship level. These two passports support assessment and hotspot analysis of environmental impact, fulfilling the following objectives. The first one, the key element for more sustainable and circular products, is information. The passport bridges these information gaps over the life cycle of ships, its components and materials, by supplying valuable information on environmental footprint and circularity. This also supports the second objective. The passports enable objective decision-making. For example, in the design phase of a ship, it supplies information on what component has the lowest environmental footprint and the highest circularity, so that the designer can select the most optimal component. Or in the ship repair phase, you can find information on the paint used on the ship, or how to disassemble the ship at the end of life, and where to source the reusable parts, so we can retain that value. And that's also the link to the next objective. The passport enables circular value retention by supplying the key information on the history of parts and materials, so that the most optimal circularity strategy can be selected from the frameworks. And finally, it also enhances the circularity of materials and components during the ship's life cycle, so that at the end of life, the parts and materials can be geographically located, detached without damaging, and reused, refurbished, or remanufactured, rather than just recycled, which, like we heard before, was hopefully the last resort. And this can be done because you have updated, upgraded, and document your equipment and materials properly. And this will also give you a higher possible value for your product at the end of life. And we made sure that for the passports are compliant with all the relevant regulations, like adopting ISO 59000 on circularity, the EU Eco-Design for Sustainable Product Regulations, including regulation on digital product passport, and more focused on maritime with regulations like the EU Ship Recycling Regulation. So for my final slide, I will explain the link between Ship Circular Materials Passport, the Shipyard Environmental Performance Index, and the Ship Lifecycle Passport. The SCMP provides the information on materials and components coming from the suppliers. If you add the information on what happens to these materials and components in the shipyards by integrated into a ship, you get the Ship Lifecycle Passport. So in the words like Jorinus described it before, you have the stuff for the ship, plus what happens to this stuff in the shipyard, documented and combined in the ship lifecycle passport. A document of all the impact and information on the materials and components and processes that have formed the vessel, and that is maintained and upgraded over the life cycle of the ship to contribute to enhancing circularity and lowering product environmental footprint. And this is the link between the three I mentioned at the beginning of my part of the webinar.